Bore samples are used to determine the soil profile for the design of domestic footings. These samples are extracted from a tube that is pushed or driven into the soil. The bore samples to a depth of 3 metres are then collected in labelled boxes with the cores laid in lengths of 750 millimetres inside the box. Looking at these core samples, we start from the top left corner of the box to the bottom of the first column, which is 0.75 metres below the surface, then in order from 0.75 metres to 1.5 metres, 1.5 metres to 2.25 metres, and 2.25 metres to 3 metres, which is the bottom of the first core. In this box we also have the core from borehole 2, which in a similar manner starts from the top left hand corner of the first column and continuously in an S shape, working progressively to the depth of 3 metres, which is the bottom of borehole 2. A trained soils technician examines these cores and, based on personal knowledge, experience and other site information, logs these samples in what is called a surface soil bore log. The technician attempts to identify the likely soil type in each layer or horizon and the depth at which it changes from one horizon to another. Minor variations from each horizon allow for subdivisions such as B, B1, B2, etc. The technician also classifies the likely soil type with the appropriate USC symbol and estimates its instability based on an IPT value. The IPT value allows us to determine the amount of swelling and shrinking that each layer will undergo as a result of a change in the soil's moisture content. Highly plastic clays will obviously have a higher value than sandy clays and silts. Looking at the cores in this box, we can easily detect the fill from the grass clippings and the presence of brick fragments and other indicators that this layer is not part of the natural soil profile. From the bottom of the fill layer commences the natural soil horizons, which in this case show a high clay content and also mixed with sand and silt. A sublayer can also be seen here, which is highly calcareous. Calcareous material is identified because of its high lime content. This calcareous or lime-rich material is identified because it can be easily leached out, resulting in the collapse of the soil. Notice that the length of the cores has somewhat changed due to drying over time, so the log should be prepared as soon as possible after extraction and care taken not to shake or disturb the cores during transportation.